We're going to talk about graphing trig functions, and we're going to talk about the three basic trig functions. So there's actually 6 trigonometric functions: sine, cosine, tangent, and then secant, cosecant, and cotangent. We're only going to talk about sine, cosine, and tangent of x. And what we want to do is look at what they look like as in a basic form. What does sine x look like? What does cosine x look like? And what does tangent x look like? And then we're going to apply some transformations. So we're going to say what happens if I have a vertical shift or a horizontal shift, vertical or horizontal stretch, a reflection, all that. What happens? So when you think about that, what happens in terms of the form of the equation is it changes from just sine x and cosine x and tangent x to having 4 parameters. There are 4 different things that can affect the graph. There is a, which is multiplied on the outside of the trig function. There is b, which is multiplied by the x inside the trig function. In other words, it's sine of b times x minus h. There is h, which is subtracted from the x, and there is k, which is added to the end. And each of those values, a, b, h, and k, do something to the graph, and we're going to talk about what they do. But before we do that, we want to make sure we know what the basic functions look like and some basic information about them. So you probably have done this before when you've talked about quadratics. You would have started with y equals x squared, and then you would have done some extra work with that. You would have talked about it with linear functions, y equals mx plus b, so you're used to m being the slope and b being the y-intercept. So you've done these kind of things before, but we need to know what the basic function looks like to start. So sine x, if you think about the unit circle, and hopefully you know that, then you know that sine x is the y value. It's this value here. So it's the y value all the way around. So what we do, and we're going to graph in radians, okay, not in degrees. So we're going to have 0, then pi over 2, which is up here, and then pi, and then 3 pi over 2, and then 2 pi. And in each case, sine has a value, and it's a special value. It's 0 at 0, then 1 at pi over 2, 0 at pi, minus 1 at 3 pi over 2, and finally 0 again at 2 pi. So what that does is it generates a table of values. And what we do with that table of values is we plot it on a graph. And when we do that, you'll notice it looks like this. So here's 0, 0, right here, pi over 2 and 1, pi and 0, 3 pi over 2 and minus 1's right there, and then 2 pi and 0. So the basic sine graph looks like that. And you might be, if you took physics 11 or 12, particularly physics 12, if you talked about waves at all, you would have talked about simple harmonic motion maybe or something like that and graphing it. And if you did, you'll notice that that looks like what you talked about in physics. It's a sinusoidal curve. It's because it's described by a sine function. So if you've heard that terminology before, it may look familiar to you. If it doesn't, then that's okay. But it looks like that. And what then happens is we can get some information about this graph. One thing we can get is that this actually has an amplitude, and the amplitude is the distance between the midpoint and the crest, or the midpoint and the trough. So the amplitude is either going up to 1 or down to minus 1. So this graph has an amplitude of 1. It's important, though, that you know where to get the amplitude. It's the highest point minus the lowest point divided by 2. Because what's going to happen eventually is you're going to be given an equation that doesn't have an amplitude of 1. It might have an amplitude of 2 or 3. So you have to know that that affects the highest and lowest values. And then after you're given equations, and we talk about those for a while, then you're going to be given graphs and ask for the equation, and you're going to get it using this formula. So it's important to understand where the amplitude is coming from. And when we say highest, we're talking y value. So highest y value is 1, lowest y value is minus 1. And then you subtract them, so you get 1 minus minus 1, which is 2, and divided by 2 is equal to 1. Okay, so we have a max value of 1, a minimum value of minus 1, and an amplitude of 1. Then we talk about the period. Okay, and the period is the distance before this repeats. You'll notice this graph repeats. It just keeps going over and over again through the same points or sets of points. But the period is one full cycle. So we've gone up, go back down, go back to the middle, and then you'll notice if we start here at 2 pi, it would go up again, just like it did back here. So it starts to repeat. So it starts at 0 and goes to 2 pi, so our period is 2 pi. All right, so it's the time it takes for one full revolution. And you would have talked about period if you took physics 11 and 12, particularly in physics 12, when you talk about pendulum motion and the mass on a spring, you would have talked about period. It's denoted by the capital letter T in that instance, but it's the same concept. It's the time it takes to make one complete cycle. And then the other thing that we want to notice is there is a range to this. The range is from -1 to 1. Y belongs to the interval from -1 to 1 because, again, the lowest point is -1 and the highest point is 1. And then we have what's called a sinusoidal axis. And you might think, what in the world is that? So a sinusoidal axis is basically the line that describes the middle of this graph. Okay? So right in between the highest point and the lowest point is this line. And this line is y equals 0. So it's the middle of the graph. And then the domain is just x belongs to your numbers because you can take any value, you can take the sine of it. You can take the sine of any number you want. All right. So that's what sine x looks like. And the reason that we're emphasizing the amplitude, the period, the equation, sinusoidal axis, the domain and range is that is what you're going to be asked to find when we start introducing transformations. So when we start moving things around, we're going to be asked to find those things. Okay, what's the amplitude of this new graph? What's the period of this new graph? All right, so that's what sine looks like. So if you look at cosine, we're going to focus on sine and cosine together because they're very similar. If you look at cosine, again, back to the unit circle, we use the same x values, but the y values now, in terms of table of values, come from the x value of these coordinates. So cosine is x. So it's 0, it's 1, then it's 0, then it's -1, and then it's 0 again. So you can see it goes 0, 1, pi over 2 and 0, pi and -1, 3 pi over 2 and 0, and then 2 pi and 1. So what does that look like? Well, we plot the graph, and it looks like this. So again, at 0, we're at 1. Okay, so that's 1, and then down here is -1, but we're at 0 and 1. Then we're at pi over 2 and 0. Then we're at pi and -1, 3 pi over 2 and 0, and 2 pi and 1. And what you probably notice, if we jump back to the sine graph really quickly, it looks almost identical. It's just moved over. So in other words, I just moved everything that way. So that means the features of it are very similar. So the amplitude's the same, the period's the same, the sinusoidal axis is the same, and the range is the same, and the domain is the same. So for sine and cosine, the only difference is that it is shifted. There's a phase shift or a horizontal translation of pi over 2 radians. So it's just moved by pi over 2. So that's sine and cosine. And what we want to do is we want to say, okay, now that we know what they look like, what happens when we introduce, if we go back here for a second, these A, B, H, and Ks? What do these do to the graph? That's what we want to know next, all right? So in terms of what they do, I'm not going to go through in much detail and show you too much about this, but basically what happens is each of them does a particular thing to the graph, and it also influences a particular characteristic of the graph. So it will move the graph either left and right, up and down. It might reflect it, it might stretch it, and then that also corresponds to something like the period or the amplitude or the domain and range. So we're going to do a very simple exercise. I'm going to show you with this graphing program just quickly what these things do. Okay, so I'm first of all just going to define a variable a, and I'm going to set it at 1 for right now. But then what I'm going to do is I'm going to put in a times x, or a times sine of x, sorry, so we can see what a does. So right now a is 1. So this is sine x. It looks like sine x. And what I'm going to do actually, just for showing it as a multiple of pi, I'm going to go up by pi over 2, and I'm going to ask this to show it as a multiple of pi. So you can see at 0, it's at 0, at pi over 2, it's at 1, and so on. And then we're just going to zoom in a little bit, so we're only looking at one cycle of the graph, okay? So what I'm going to actually do now is I'm going to ask this thing to animate a. I'm going to ask it to change the value of a, and I'm going to ask it to go from -5 to 5 in steps of 1. So you're just going to watch as this moves. Okay, so now it's at -5. So you probably can notice a difference already that the highest point jumped to 5 and the lowest point jumped to -5. You actually can't see it because it's down so far. The other thing you might notice is that it starts out now, instead of going up like it did before, it's going down first. So I'm just going to hit play and you just watch what happens. So hopefully you noticed what A does to the graph. A moves the graph based on the amplitude. It affects the amplitude or the stretch. And if it's negative, it flips it upside down, which is called a reflection in the x-axis. So as I go negative, you notice it flips. There it's positive, 1. That's the original graph. This is now -1. It just flips it upside down. Okay? So that's what A does to the graph. If we look at B, I'm just going to change this, and I'm going to still use A in my graphing program, but I'm going to put it in here. So I'm going to go A times X. All right? So this is now the parameter B. If we look back here, okay, I'm going through A. We know what that does now. So I'm just going in order. Now I'm looking at B. What's B do? So I hit play on this again, and I just want you to watch what happens. B is going to start. I know it's A in my function, but it's going to start at -5, and it's going to go to 5. And just watch what happens. So you can probably see after having watched it that this does the same thing when it's negative. It flips the graph. So there's where it's positive. Sorry, +1 is here, and then -1 is here. So it flips the graph exactly like the A did, but it's actually technically a horizontal value, so it actually flips it around the y-axis. Now that doesn't have any practical difference in terms of what the function looks like, but just in terms of mathematically what it's doing, it's actually flipping around the y-axis as opposed to the x-axis. But the other thing it does is that as it gets big, it makes the period smaller. In other words, one rotation takes less time. So when it's 2, you notice now, if I start at 0 and I go up and down and back up, I'm at pi. So I've actually taken the period and halved it when b is 2. And if I go up to 4, it'll actually be a quarter now. Right? So one full cycle now only takes pi over 2 when it used to take 2 pi. So that's what b does to the graph. Okay? Then we want to know what h does to the graph. So what I'm going to do is I'm going to just change this and put it in as x minus a. All right? So we're going to, again, just ask it to animate, and I just want you to watch. It's going to start at -5, and it's going to go to 5. Okay, and if you watch that, I think you can clearly see what it's doing. If it's positive, it's moving it to the right, and if it's negative, it's moving to the left, but it's essentially just moving it left or right. Okay? If it's negative, it's moving it to the left, and if it's positive, it's moving to the right. However, that means that in the equation itself, if you look back here, it's minus h. Okay, so just understand this. If it's minus h and h is negative, then in the bracket, it's going to look like x plus h. Okay, there's going to be a plus sign because a minus and a minus make a positive. So that's what h does. And then finally, we want to know what k does. So all I'm going to do is I'm going to change the a value, and I'm going to move it out here. So I'm going to put plus a out here. Again, it's going to animate from -5 to 5. And I'm just going to get you to watch, and you can watch what it does. You might be saying, where's my graph? Well, just watch. It'll come back. So I think watching that's pretty clear what k does. It just moves it up and down. So if it's positive, it moves it up. If it's negative, it moves it down. That's why we couldn't see it at -5. All right. So that tells me what h and k and a and b in my graph. So I'm going to go back here, and I'm just going to make this full screen for a second so you can see all of them at once. But what it does is it affects different things in terms of what the graph looks like, and it also affects different things in terms of the amplitude, period, and all of that. All right. So K moves the graph up and down. We just saw that, but it also tells us the sinusoidal axis. So the sinusoidal axis is y equals K. So K tells us up or down, vertical shift, it's called. Okay, so you'll hear it termed the vertical shift or the vertical translation. So you'll sometimes be asked to find the vertical shift or vertical translation. What is that? Well, that's just the up and down, all right? And it also tells me the sinusoidal axis is y equals k. And then I just made a note that this is only used for sine and cosine because tangent doesn't have a sinusoidal axis, all right? K still is used in tangent, but it's not a sinusoidal axis. Then this moves it, h moves it horizontally, positive h moves it right, negative h moves it left. So that is called the horizontal shift or translation. And actually sometimes you'll hear it called a phase shift. So it's the horizontal shift or translation. I'll just write that down for you and you can follow along in your notes. It's also called, sometimes instead of the horizontal shift, it's called the phase shift. And then B affects the period, and we said if B is 2, then the period becomes smaller. If B is big, it becomes even smaller. And if B is smaller, if that makes sense, if B is 1/2 or 1/3, if it's a fraction, then the period is actually stretched horizontally wider. So it's 2 pi divided by B. Okay. And then the amplitude is coming from A. So the amplitude is A, but I want you just to notice something, or know something, I guess, not notice something. The amplitude is A, but it's the absolute value of A. In other words, the amplitude is never negative. If A is negative, there's also a reflection in the x-axis. So we can write that in. If A is negative, we would describe the transformation as a reflection in the x-axis, meaning it flips over the x-axis. And if B is negative, we say the same thing, except it's a reflection in the y-axis. So if you're asked to describe the transformations, that's what we say. So you might be saying, okay, that's a lot of information. What does that mean? Well, it means that we can actually take all of our A, B, H, and K and figure out what that is going to do to my graph. And then I can actually figure out my new points. In other words, my new points that describe where the graph has gone. So in order to sketch the graph, which is essentially what you're going to be asked to do, ultimately, you're going to be asked to state all that stuff, amplitude, period, domain, range, and then you're going to be asked to draw the graph. You've got to make a table of the original values. And the original values are the ones we talked about a few slides ago. So if I jump back there, I'm talking about these, okay, for sine. And then cosine, these are the original values. So that's what we're talking about when we say take the original values. And then your new x value, you're going to take the old x value, okay, and I'm going to just put in xo, just so you know that's the original x value, and I'm going to put yo here. So I'm going to take the original x value, which in this case is 0, I'm going to divide it by b and add h, and that's my new x value, okay? And the same thing with y, I'm going to take the y value, and I'm going to multiply it by a and then add k. So it's actually a fairly simple process once we get into it, and I'll show you a couple of examples. But it's important that you know how to do the transformation to get those new points. And then once we have the new points, we just plot those points as our graph, okay? So let's look at an example. So let's graph y equals sine of x minus 90 degrees plus 2. Okay, we're going to do this in degrees because this is 90. Okay, so we wrote the table out. I said before we wrote the table out in radians. We were only doing radians because there's no sense in writing both, I don't think. But now that we know this is in degrees, okay, then we know, okay, our tables that we wrote out back here, I need to change my x values to reflect that. So this would be 90, 180, 270, 360, okay? So I didn't write them out here. You can go back and fill them in if you want, like 90, 180, and so on. I'm not going to do that because I don't think it's necessary. But what this also tells me is that is an h value of 90. And this 2 is my k value. So k is 2. Now, a and b aren't really there. B would be right there, a number multiplied inside the trig function. There's nothing there, so b becomes 1. And a would be there, and since there's no number there, it's 1. Okay, so we're asked to graph this and then state the period, amplitude, and equation sinusoidal axis. The cool thing is I can state the period before because I know the period is 2 pi radians, or 360 degrees divided by b. So if b is 1, the period is just 360 divided by 1, or 360. Okay? I can state the amplitude because the amplitude is my a value. So the amplitude is just 1. And then I can state the equation of sinusoidal axis because that is y equals k. So in this case, it's y equals 2. So I have my information. Now I want to draw the graph. So to draw the graph, we're going to take our original points. Our original x values are 0, 90, 180, 270, and 360. Our original y values are from here. They're 0, 1, 0, minus 1, and 0. Okay, because it's sine x. If it was cosine, they would be different. So here's my original y. Okay, 0, 1, 0, minus 1, and 0. So then what I do, if you look back here, is I take the x value, divide by b, and add h. So that means I'm going to divide by 1 and add 90. And the y value, I'm going to multiply by a and then add k. So it's 1y plus 2. So we're just going to do that with each of these values. So 0 divided by 1, 0, plus 90 is 90. If you're wondering why you just have 90 there, what I did is I went x is equal to 0 divided by 1 plus 90. Okay? And then to get this y value, I went y is equal to 1 times 0 plus 2. I'm just plugging the old y value, right? I just changed this x to 0 so you can see what I mean. And I'm just dividing by b and adding 90. So 90 divided by 1 is 90, plus 90 is 180. And 1 times 1 is 1, plus 2 is 3. Okay, so I'm just plugging them in. If I plug in 180, I'm going to get 270 and 2. Then I'm going to get 360 and 1, because minus 1 plus 2 is 1. And then finally, I get 450 and 2. You will notice that this still jumps by the same amount. Okay, so this was jumping by 90. This is still jumping by 90 because the b value is 1. So if you have the original point, 90, you can just add that same jump if that helps you. And you'll notice there's a repeating in these as well. So every time there's a 0, here there's a 2, right? You don't actually have to do that calculation 3 times. You just have to know what it is once and then repeat it. So I've already stated these, the amplitude and the period, and I've already stated the sinusoidal axis, but you also should notice that when h is 90 and k is 2, if somebody says describe what's going on, you need to be able to describe it as a horizontal translation of 90 degrees to the right, because h is positive, and a vertical translation of 2 up. Okay, so that's how I describe the transformations. And then I'm asked for the domain and range. Now, the domain is x belongs to real numbers for all sine and all cosine, every time, anytime, it doesn't matter. So that's easy. The range, you just look in your table. The highest number in my table is 3, and the lowest number in my table is 1. So my range is from 1 to 3. Okay, biggest number. So the minimum number goes first, and then the maximum number goes second. Okay, now we're going to draw a sketch. So to draw the sketch, I'm going to first of all establish a scale. The scale is going to be, I'm going to go up by 90 because these all jump by 90. Okay, so I'm going to go up by 90. So I'm going to go 90, and then 180, 270, 360, 450. Okay, and then you can keep going after that if you want to. But that's what I'm going to do for x. For y, I have to go, lowest is 1 and highest is 3. So I'm going to go 1, 2, 3. Okay. And then I'm just going to plot these points. So the first point I got to plot is 90 and 2. So it goes here. Then the next point is 180 and 3. So that's 180. There's 3. Then I'm back down to 2 at 270. Then I'm down to 1 at 360. And at 450, I'm back at 2. So my graph looks like this. Okay, and then I'm done. So that's how you draw the graph and state everything. Okay, so we'll do one more example. This one with cosine. So graph y equals 3 cosine x minus 2. So the first thing I want to notice, I want you to always do this, is identify that that is a, that 3, and this minus 2 is k. K is minus 2. And b, because b is not there, b is 1, and h, because there's nothing added or subtracted, is also 1. And that's really important because everything depends on a, b, h, and k. If you can establish what a, b, h, and k are, you're golden. If you can't do any of this. All right? So, given that b is 1 and h is 1, thinking about this is x over b plus h now becomes x over 1 plus 0, which essentially means that x, if you simplify this, is just x. In other words, x isn't changing. And then y is ay plus k. So now it becomes 3y, a is 3, plus minus 2. Okay? Now, our original x's aren't going to change. They're always the same for sine and for cosine. So that's easy. You're just using the quadrant. So 0, 90, 180, 270, 360. The original y values are going to come from cosine. So cosine starts at 1. If you jump back and look, it starts at 1, and then it goes to 0, then to minus 1, then to 0, and then to 1. Okay, so we're going to jump back here, and we're going to fill those values in. Now, the x values aren't changing, so that's easy. The x values just get copied over. The y values are, though. So what we're going to do is we're going to take our original y value. I'm just going to do it with 1. All right, so I'll just circle it with a red marker and then do it over here in red. I'm going to go 3 times 1 minus 2, so that gives me 1. Okay, then if I do the next one, let's say I do that one in green, I'm going to go 3 times 0 minus 2, and that gives me minus 2. Okay, so that's where I'm getting those values from. And then if I go back to, if I do minus 1, let's say I'll do that in blue. So I go 3 times minus 1 minus 2, that gives me minus 5, right? Minus 3 minus 2. And so that goes in my table. And then what's nice about this is I already did 0. I know it's minus 2. And I already did 1. I know that it's 1. Okay? Now, it asks me to state the period, amplitude, and equation of the sinusoidal axis. So again, the amplitude comes from the a value. It's 3. The period comes from the b value. So it's 360 divided by b. So it's just 360. H is 0, so that tells me there's no horizontal translation. And k is minus 2, which means I'm shifting, vertically translating down 2, okay, because it's negative. Then the sinusoidal axis, again, is y equals k. All right, if you want to just write that in up above it, just so you know. And then the domain, always x belongs to real numbers. The range, again, we go back up to our function and we say, what is the biggest number I see? And the biggest number I see is 1. So that's the biggest number, so that's my maximum value. And the minimum value I see is minus 5. So my range is going to go from minus 5 to 1. Okay, so it looks like this. And then I have to draw a sketch. And again, to draw the sketch, I'm going to look at x. It's going up by 90, so I'm going to go 90, 180, 270, 360. Okay, and then a couple more. And then the y values, the minimum is minus 5 and the maximum is 1. So I'm going to go up by 1, but I'm going to go, here's 1 in my y. And then I'm going minus 1, minus 2, minus 3, minus 4, minus 5. So there's minus 5, here's minus 2. And so it starts at 0 and 1. Okay, if you look back up here, then it goes to 90 and minus 2, which is right here. Then it goes to 180 and minus 5, which is here. Then it goes back to 270 and minus 2. And then finally 360, it jumps back to 1 if you look back up here. So my graph looks like this. Goes up, down through here, down through here. Oop, just missed. There we go. Back up. And then back down. And it would continue. And it's good to know that. In other words, the pattern you'll notice is it's going from 1 to minus 2 to minus 5 to minus 2 to 1. So the next point is going to be at minus 2. And then the next point would be at minus 5 if you wanted to continue your graph. So it's going to keep going down like this. You don't have to, but it's good to know that that's what it would do. All right. So that's the idea. Okay. Here's another example, and I think I actually will just leave that for you to try. And there's a few other things that your teacher will give you to try, but just I'm not gonna graph it. I'm not gonna draw it just because for the sake of time, this video is getting a little long, and I don't want to lose you, but I want you just to state everything. So what I'm going to do, I'm going to encourage you to always write down A, B, H, K. All right. So A right here, A is 2. B, 1. H is 180, but it's negative, okay, because it's a plus in here. So when you have a plus in here, it means the H is negative. We talked about that. And the K is right there, so K is -2. Those all tell me something. A tells me the amplitude, so I can state the amplitude is 2. B tells me the period. The period, it doesn't directly tell me the period, but the period's always 360 in this case because I'm in degrees, right? Because this is in degrees. Divided by B. So the period's 360. The H value being -180 means I have a horizontal translation. I'm going to just abbreviate that H of T of 180 degrees, and it's negative, so it's going left. And then I have a vertical translation from K of 2 down because it's negative, okay? So then I can also state the sinusoidal axis, all right, which I will abbreviate SA for simplicity, is y equals k. So in this case, it's going to be y equals -2. Okay, and then the domain, I can state that because it's always x belongs to the real numbers. And then the range, all we have to do is we know the original range starts from -1 to 1. So the things that affect that are your amplitude. Okay, so if you multiply it by a, so we times by a first, and that gives me y belongs to a is 2, so -2 to 2. And then k moved everything down 2, so I'm going to subtract 2 from each of them. Okay, that's my k value. And that gives me a final range of y belongs to the interval from -4 to 0. Now, you can get that from your table, which is what I did in the 2 examples. I'm not suggesting you have to do it that way, but if you want to, you can just multiply the numbers, the original range by a, and then subtract k from each of them. Okay, and then to draw the graph, you would just make your table and draw the graph. And so I'll make the table with you, and then we'll leave it at that. You can plot the points on your own because I think you're all capable of doing that. So the original x and then y, original x, we're going to go, just going to scroll this down a little bit, 0, 90, 180, 270, and 360. Okay, those are my original x values. My original y values, so I'm just going to say y 0 instead of writing original again because you don't want to watch me do that, are 1, 0, -1, 0, and 1. So now my new ones, I'll just say x new, so xn, and then yn. I got to figure out what are those going to equal. So it's x, they're going to equal x over b, so x0 divided by b, b is 1, plus h, so -180, okay? And then the y is going to be ay plus k, so they're going to equal a is, if you look back up here, because I can't see it, it's 2, so it's going to be 2 times y0, and then plus k, and k is -2, so 2y minus 2, okay? So I'm going to fill them in. 0 divided by 1 is 0 minus 180 comes out to -180. And then essentially all I'm doing, if you look at this, is I'm just subtracting 180 from each of these numbers. So 90 minus 180 is -90. And then 180 minus 180 is 0. And then 270 minus 180 is 90. And finally, 360 minus 180 is 180. And then for y, I'm going 2y plus 1 for the first one. Okay, or sorry, 2y minus 2. I don't say what. Y is it plus 1, so I get 0. And then I'm going 2 times 0 minus 2, so that gives me -2. Then I'm going 2 times -1 minus 2, that gives me -4. And then 0 I already know, right, because I did it here, so it's -2. And then finally 1 I already know because I did it up here, so it's 0. So those are my x values. And you'll notice again, if you look at this now, if you look at your table to get your range, there's my highest number, that's my max. okay, which I put here. And this is my lowest number, that's my min, and I put that there. Okay, and I'm going to leave it there for you to just plot the points yourself, but those are the points you would plot. Minus 180 and 0, minus 90 and minus 2, 0 and minus 4, 90 and minus 2, and then 180 and 0. There's lots of other examples that I'm sure you're going to be asked to do, but that's the premise, and hopefully that makes sense.